So I'm back here the next day to do this Mercedes, and I have another one in, another Mercedes in there I'm doing, but I wanted to test this one because I'm here and I don't have to be here. I'm here to test this one. Well, I'm here to do the one inside, but I want to test this one after it's been new compressor, new receiver dryer. I want to test it. It's hot, soaking in the sun. It's been here all morning, and so I'm starting off from a hot soaked vehicle. You see where the 115 degrees is right there? That was when the temperature sensor that you see right here was on the seat. So it's 115 degrees down there in the well of the seat in the shade, 115 degrees there. Then you see the temperature rise here at 146 degrees. It's 146 degrees here at the dash. So I want to know the interior dash temperature because I want to put a heavy heat load over the evaporator and do a drawdown test and see how this vehicle and the compressor. And it'd be nice if you have the scan, they got the scan tool, but if you have the scan tool, you can look at the duty cycle commanded to the compressor because it's a variable displacement compressor, and you could do a lot of playing. Then as you see, I just took out from 146 degrees here to sticking it down to dash. So you got 12 inches down, deep down to dash to find out what is the temperature of all the plastic material underneath, deep down inside, not on the surface. So where are we going to? It looks like we're heading towards 142 degrees. So it's not that it was just parked out here 10 or 15 minutes ago. It's been here so many hours that all the plastic, the metal, the wiring, everything is at the 140 degree level. 141 degrees. So there's a lot of mass of material that needs to be cooled down in this vehicle. So this is optimal for testing. If we look at the pressures, you see the liquid side is 94 psi right here. The suction line is 103. You go, well, how can a suction line right here have a higher pressure than the liquid line? Well, remember the hard shut-off expansion valve? Remember a compressor? You can't pass gas through a compressor. That's another sealed off part. So the high side is separate from the low side. Well, where's this low side located? The mass, the most surface area. Well, you got all the piping that's going under the dash. You got the heater box, and you have an evaporator core. What is the temperature of this evaporator core right now? Well, what I have, 140 some degrees. We got, oh, it's down to 135 degrees. So we have 135 degrees there. So what's the pressure temperature relationship to the gas? But we do have cooler out here. So what happens under this? When you're out here, we are the suction line. Where are we? I'm having an issue here, guys. Help me, help me. You got freaking guy here with the, I'm having a problem. Oh. Jesus Christ, there we go. So suction line is 89 degrees. Liquid line is base 8. They're both 90 degrees. 89.9, 90.8. Right here and right here. This is 90 degrees. That's 140 degrees. So in what direction does the gas move? So in these scenario, the gas gets baked out of the evaporator. Any liquid in there is gone. It's vaporized. And where does it go? Well, it's 90 degrees out here. So the vapor leaves there, comes to here where it's cooler, it goes beyond the saturation point, and it turns to a liquid, and it migrates, and it sits down in the compressor, the receiver, the bottom of the condenser. There's no liquid at all inside the evaporator. It's all been pushed out here just from the hot soak because it's 140 some degrees right there. All right, next video.